Okay, so here this time I have m of x equals to integral of negative 2x dx. And one thing that you have to be careful is that p of x should be including the minus sign also. Okay? So that this is e to the negative x squared. Therefore, if I multiply e to the negative x squared both sides, the entire left side will be a product rule. And then this side will be same as, here's a quick way to do it. It's just this one without the y prime. It's just y. And prime is to the entire thing, not just the y. So this is same as that one. If you are confused about what product rule gives you this, just copy this down with parentheses in there. Then you're not going to be confused. Now integrate both sides by dx so that the left side, the integral and the derivative cancels. Now in order to do this one, you need to use u substitution, because if you set u equals to negative x squared, then du is negative 2x dx. See, when you have a product of two functions, then that means you need to either use integration by parts or use substitution. How do you know which one to use? Well, here's the rule of thumb. Just pick up the one that seems to be the inside function. See if the derivative of the inside function is some constant multiple. See, if you differentiate this as negative 2x, and this is 3x, so 3x is some constant times negative 2x. Is that right? Yeah. In that case, you use a u substitution. If that's not true, then that probably means you need to do integration by parts, which is equivalent to tabular. Now, there are some cases where you have to do both. You first, especially when you have e to the negative x squared, it can't be tabular because the antiderivative of e to the negative x squared, it cannot be written in closed form. So in that case, you first have to do the u substitution, and maybe you, in some cases, some harder cases, you will still have to do tabular after the u substitution. Okay. Here it's just a u substitution, nothing more. So if I solve this for dx, I have dx equal to du over negative 2x, and then I can rewrite this integral as 3x times e to the u times du over negative 2x. See, I replaced dx by du over negative 2x and negative x squared by u. X cancels. Negative 3 over 2 can be pulled outside. And now I have to integrate u, e to the u by u, which is just e to the u. And then you go back to your original substitution. U is equal to negative x squared. So that's what you have. And you're almost there. Now I have e to the negative x squared y equals to negative 3 over 2 e to the negative x squared plus c. However, this doesn't satisfy the given initial condition. We have to, sometimes the initial condition is not given, but if it's given, you have to make sure that it's satisfied. So what does that mean? If x is equal to 0, I want y to be equal to 1. So let's see how that applies. If x is set to be 0, I have e to the 0th power, which is 1, times y, equals negative 3 over 2, e to the 0, plus c. That's 1, y is 1. So you end up with equality that 1 is equal to negative 3 over 2 times 1 plus c. So c is equal to 5 over 2. C is equal to 5 over 2. And then what? C is 5 over 2. And you put it back and you solve for y by dividing by this. So let's see what you get. If you divide by e to the negative x squared, that goes away, but this will be divided by e to the negative x squared, right? So it'll be negative 3 over 2 plus c is 5 over 2 divided by e to the negative x squared. You can further simplify this, but I don't care. As long as you solve for y, that's good. Maybe I should write the answer here. It might not be recorded. So I'm rewriting the answer here. Y is equal to negative 3 over 2 plus 5 over 2 divided by e to the negative x squared.